I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss parametric equations. These equations will be converted to Cartesian equations. We'll find domain and range of Cartesian equations. Trigonometric parametric equations will also be taken with exam style questions. Our approach, engaging minds, help for creative thinking and problem solving. In this video, you will see how we are going to relate the equations, connect them with the context, follow very simple steps to visualize solution. Engaging minds help to develop both mathematical and social skills, gain confidence, and get ready for the future. Give the gift of education. I can be part of your success story, build strong foundation, and show bright future. You can always contact me on the address given. Join Anil Kumar classes. Let's enjoy the lesson. Hi, Abby. How are you doing?
Hi, sir. Yeah, I'm all right, thank you. How are you?
Very good, very good. So today, what do you want to do?
I was hoping if you could, continue with the parametric equation side of the math pure side of the course, and moving to kind of trickier questions based on this.
No problem. So I'd like you to share the video. Till now, you have understood all the concepts, right?
Yes, I have.
Right. So you can share whatever material you have. We'll begin from there.
Okay. Let's get this up. So I think we ended on like trying a couple questions from here from part one.
Yes.
So could we try, one of these circled ones here, where t belongs to real numbers and t is not equal to 0?
Right.
So part A, determine the ranges of x and y in the given domain of t.
Let's try to do this. Can you reduce the screen so that I get some space to work?
Yeah.
So we have
large if it's too small.
X equals to, you can read the equation for me, 3 over t.
3 over t plus 2.
And we know t is not equal to 0. Is that okay?
Yeah.
So if t is not equal to 0, what is the range of this particular function? So R of
x is not x belongs to real numbers, but it's not equal to 0.
And x is not equal to 0 because
x is the other.
Yeah.
So x is y in this case.
So now you say x is not equal to 0. Let us say we have to look into this once again. If I sketch this function, let's try to sketch this function.
Oh, because of the plus 2. That's an asymptote.
Yes.
Yeah, asymptote. I was going to realize, yeah. So it wasn't just 3 over t.
Horizontal asymptote at 2. You get the idea?
Yeah. It's always best to just sketch.
Yeah, it's good to sketch, right? So if t is positive, then we get something like this, correct? T cannot be 0. That means we have this vertical asymptote. Is that clear to you?
Yeah.
Correct? So it means what? It means that t is not really equal to 2. Is that okay? All of the values x can have, right?
Yeah.
So we have the range of x. Let me rewrite now here. Range of x is x belongs to real numbers, but x is not equal to 2. Is it okay?
Yeah. What about 0?
No, that is the input t, right? T is not equal to 0.
Oh, I think because it's all x and t. Like if I saw in terms of y and x, I'll be like, yeah, okay.
Yeah, you understand. If I put 0 here, I can still solve it. You get the idea? Let me put x equals to 0. And then it is 3 over t plus 2, right? I'll bring 2 to this side, right? It will be minus
and
cross multiply 3 over t, correct? You get the idea?
Yeah,
then
yeah.
t is equals to minus 3 over 2, correct? So for t
Oh,
equals to minus 3 by 2, we do have a 0. You get the idea?
right,
Which
right.
is the x-intercept, which is minus 3 by 2. Is that clear to you?
Yeah. Whereas
Now,
when you made x equal to 2, when you solve 2 minus 2, you get 0. It will
yes.
lead to math error because of the asymptote. So therefore, it has to be not equal to 2.
The
Yeah.
horizontal asymptote is 2, and therefore x value is not going to be 2 in this case, and therefore the restriction will be x not equal to 2. Do you understand?
Yeah.
Not 0. So this is very important point to consider. Is it okay?
Yeah.
Output, and x becomes the output. T is the parameter. Okay.
Okay. Yeah.
Now let's look into the second equation.
So
Equation is,
y equals to 2t
yeah.
minus 3 minus t squared.
Let's rearrange. Minus t square plus 2t minus 3, right? Let's find the vertex for this. So you can take minus common. T square minus 2t. Let's keep this minus 3 outside. Half of minus 2t is 1. So we'll add and subtract 1, right?
Is this complete in the square?
Yes.
Oh, okay.
To find the vertex. We could have found directly also minus b by 2a, but let's do this. So minus, and we get t minus 1 whole square, and there we have minus 1 minus 3. Let's open the bracket. Minus t minus 1 whole square, minus and minus becomes plus 1 minus 3. So we have minus t minus 1 whole square minus 2. So we have a parabola which is kind of like this. Let me just sketch this parabola, where the vertex is given to us as 1 minus 2. Is that clear?
Yeah.
However, t is not equal to 0, right? T is not equal to 0. So if t is made 0, where will there be a hole? Can you tell me?
So 0 in the equation would make it
Minus 2
minus
minus 2.
3
So that point will be a
minus.
hole, which is minus 3 for x value and 0 t, right? Is that clear to you? There is a hole there, correct?
So t is 0, yep, and y is minus 3.
However, we do have a value of minus 3 on the right side because this is the axis of symmetry. Is that okay? On the
Oh,
right
yeah,
side,
that's 1 unit
if
back.
you put t equals to 2, 1 unit to the right, you will get minus 3, correct? You can substitute and check.
Yeah, I was just checking. So 2 times 2 is 4, minus 3 is 1,
So 2 minus 1 is 1, 1 square
minus
is
4,
1,
minus
minus
3.
3 minus 2 is minus 3, correct?
Yeah.
So you do get this value. And therefore, the range for y is what? Let me write down here. So range for y is equal to that y belongs to real numbers so that y is less than and equal to the maximum value of minus.
Minus. Oh, wait, is it not minus 2?
Oh, yeah, minus. Sorry. This
Oh,
is
okay.
minus 2. Sorry.
Yeah, so that's what you were saying about if you didn't sketch it and find the vertex, you would think that it's at minus 3 because when you sub in 0, you think, or because of the minimum, or in this case, sorry, the maximum,
Right.
that's another, step for the range. So you have to do it from there. Oh, that's a trick. Okay, cool. So minus 2.
Yeah, so don't jump to conclusion. Look at it very carefully, okay?
Yeah.
Okay. So you can note down, I'll erase this. So we got the range of x earlier, and now for y, it is less than equal to minus 2. Is it okay?
Yep.
And what was the range for x? Not equal to 2, right?
Yeah, I wrote them down.
Now let's do part B. What is part B?
Part B is show the Cartesian equation of C can be written in the form of y equals a, x squared plus bx plus c over x minus 2 whole squared.
Correct. Now, so basically you have to isolate t from one equation and plug it in the other equation, correct? So from x, we will isolate since y is the output from Cartesian equations, right? So
Yeah.
the concept here is that in Cartesian equation, y is the output, correct? Whenever you draw, you have to say that this is your y and this is x. So y is the output. So we'll isolate t from x. From x, we can say x, we have x equals to 3 over t plus 2. Isolate t, what will you get? X minus
3
2
over x minus 2.
3 over 2. And so t equals to 3 over x minus 2. Substitute this in y. So y is equal to 2t, which is 3 over x minus 2, correct?
Yeah.
Minus 3 minus t square, which is 3 over x minus 2 whole square. Is it okay?
Yeah.
So now we have to
expand.
So x minus 2 whole square is in the denominator. Let's take this x minus 2 whole square in the denominator. Even in the equation, it is x minus 2. So do not expand denominator, right?
Yeah.
In the numerator, we get 2 times 3, 6 times x minus 2. And then we get minus 3 times x minus 2 whole square. And here we get square of 3 is how much? 9, right? So we get minus 9. Is it okay?
Yeah. Oh.
Do you understand? We squared it. So if you could reduce my screen, I will further simplify this.
Yeah, is this similar to like partial factoring? Or no? This is just taking common denominator.
Yeah, you do not partial factor in this case since they want ax square plus bx plus c in the top, right? So just expand and simplify, right? So you can do this work. You can say x 6x, right? Open the bracket, minus
12
minus 3 times. When you open this up, x squared, so 3x squared, minus 2ab means 4, 4 times 3, 12.
Minus 12x plus 12x.
And 2 square is 4, 4 times 3, 12.
Plus 12.
9 over x minus 2 whole square. Is that clear to you? Now rearrange the terms. We have minus 3x squared. Let me write down here. Minus 3x squared. As far as x is concerned, we have 6x and 12x will make this 18x. Constants, minus 12, and minus 9. So minus 24 and minus 33 over x minus 2 whole square.
Yeah.
You want something where a is a common factor, 3 is a common factor here. So let me take minus 3 as a common factor. Okay.
So we got 3
x squared
minus x squared. Oh, you took minus 3 out.
I took minus 3 out. Okay.
Okay.
And plus 11 over x minus 2 whole square. Is that clear? So a for me is minus 3. And then what else? B is the coefficient of x. So b is minus 6. And c is constant, which is 11. Is it okay?
Yeah.
So that is what will be my answer. I'm taking a as minus 3. Is it okay? So we have, because they also have x squared. So we have to keep this x as positive. You get the idea?
Oh, I was just about to ask, how do you know it's minus 3? Yeah.
Yeah. So that x squared is positive. So they are not asking for coefficient of x squared.
Yeah. So look at the like I guess variables in the question to see whether you take out maybe a negative or not.
Yes. So that is the solution for this part. Is that clear to you?
Yeah.
Absolutely clear. Perfect. Now we can move on to the next question. So you understand, we are looking for output of x, output of y as the ranges of the two. Okay?
Yeah, yeah.
Select. Which question do you want to do?
Oh, we still want to part of this one, sir, or move on? Because I think that's another, using trig identities is kind of different.
Let's take a trig question. Yeah. No problem.
Okay. There are some examples here. Should we maybe
go?
Let me just quickly enlarge there. So using trig identities, you can use trig identities to convert trigonometric parametric equations into the Cartesian form. In this chapter, you will always, consider angles measured in radians. So example 3, a curve has parametric equations x equals sine t plus 2 and y equals cos t minus 3.
Correct. So as far as the trig identities ME is concerned, we know the Pythagorean trig identity. You know sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta
Cosec.
is cosecant square theta, right? So
Yeah.
these are the trigonometric identities which you could use. The other ones are a plus b formula. So we say sine of 2 theta, let me write 2t now, is 2 sine t cos t, correct?
Yeah.
And cos of 2t
Cos 2t.
can be written in 3 different forms. Can you reduce the screen? I'll write down clearly. You can see it better.
Yep. More or is that
More.
Oh.
I think it should be visible. That's good. Very good. So cos of 2t is cos square t minus sine square t, correct?
Yeah.
And we could also write as 2 cos square t minus 1 or 1 minus 2 sine square t. Is that okay?
Yeah.
So these are the trigonometric equations which you could use to simplify these equations, correct? Can you tell me now what is the equation of x given to you in example 1? We'll just do it on the side. Read.
Okay.
Read. Read.
Sorry. 2 sec. So we've got x equals sine t plus 2 and y equals cos t minus 3. So it's saying show that the Cartesian equation of the curve is equal to what they've given.
Correct. So let's find the Cartesian equation. So basically, we want to eliminate t and we want to get only x and y. So sine t can be written as what? Sine t equals to x minus 2.
X minus 2.
Cos t is equals to y plus 3, correct?
Yeah.
Since we know that sine square t plus cos square t is equal to 1, we have x minus 2 whole square plus y plus 3 whole square equals to 1. You get the idea?
Oh, yeah.
So we have eliminated both sine, cos, and t parameter, and we have x and y, and this is, a circle, correct?
Yeah. Oh, yeah. X squared plus y squared equals
this center as 2 and minus 3.
2 and minus 3.
Radius equals to 1. Is that clear to you?
Yeah.
So it's not very difficult using trigonometric identities, just as we did. It was pretty easy, right? So
sketch the curve. Yeah. That's done. Oh, that was really nice. I like that one.
Correct. You can take more examples. Let's take example. Let's go through example 2 also. Doesn't matter.
Oh, okay.
The variety which they expect us to look into.
Sorry, repeating around. Okay. A curve is defined by the parametric equations x equals sine t and let me just write that down.
Y equals to sine 2t.
Yeah, sine 2t, where t is in between pi over 2 and minus pi over 2.
Correct.
Find a Cartesian equation in the form of y equals f of x, and then write down the range of f of x.
Correct. So basically, let's write down x equals to sine t, right?
And y equals to sine 2t.
Sine 2t. So sine 2t, as I said, can be written as 2 sine t.
2 sine, yeah. 2 sine t cos t.
Sine t is x. So instead of sine t, I'll write x, right?
Oh yeah, y equals 2 x.
So from here, you know what cos t is. Y over 2x is equals to cos t. Is that okay?
Yeah.
And sine t we already know. So you get the equation sine square t.
Oh, again.
Cos square t equals to 1. And sine t is x. So we get x square plus cos square t is the square y over 2x. Is that okay?
Yeah.
So that is your Cartesian equation for the given condition. Is that clear to you?
Right. So that's also a circle.
Perfect.
No, it's not. No, it's not. Sorry.
They also given you domain for the function. Let's look into the domain, okay? What is the domain given to you?
T between pi over 2 and minus pi over 2.
Not including, right? Or including?
Including. Yeah. Sorry, I said that weirdly. Minus pi first and then pi. Like the other way. Yeah.
So minus is going like negative, right? So from minus 5, so it is in this domain. Is it okay? Is that what is written? I can't see. Okay, that's fine. So from minus pi by 2 to, so it goes like this. Minus pi by 2 to pi by 2, right? So that is the domain, correct? So anyway, we get this equation. which is the given equation for the case, correct?
Mhm.
Now,
Then,
yeah, good, yeah.
so then they're saying, so find the Cartesian equation of the curve in the form of y equals fx, giving x between minus k and k.
So we have to isolate x square from here. Is that clear to you?
Oh,
So
okay.
y equals so we have this equation here. So let's
How
take
come
x
we're
square.
isolating?
Oh, we'll take x square on the right side. So we have y square over 4x square, correct? Equals to 1 minus x square. Just take x square to the right.
Okay.
So let me rewrite this second step in between as whole square, and I'll write this as 1 minus x square. Is that clear to you?
How come we're doing this, sir?
Because
To
we
find
have
k.
no. First part, yeah. First part is y is a function of x, right?
Mm.
Equation of the curve in this form, where x is, we have to find the domain of x, right?
Yeah.
Just as we are given domain of t. So we'll have to work on the domain of x also, correct? Is that
Also,
clear?
that's why we're moving, the x.
Yeah,
And
you
I
will. We want y equals to f of x. That means we have to isolate y. So I'm taking x squared to the right hand side. Now multiplying by 4x squared.
So isolate y.
Yes, yes.
Okay, so we cross multiply that then. So do you want me to enlarge a little bit?
Yeah. So as the book has done, y equals to sine 2t can be written as 2 sine t cos t, correct?
Mhm.
And since sine t is x, 2x cos t, and we now have sine square x plus cos square x t equals to 1. So cos square t is equals to 1 minus sine square t, 1 minus x square, cos square t is 1 square root of this. Now, because cos is negative, mainly because we are in quadrant 3 and 2 and 3, 2 and 3,
2 and
right?
3. Yeah.
So substituting 2 and 3, we get y equals to, because y is sine 2t, right? So 2x the value of sine, and cos t is square root of this. So we have y equals to 2x square root 1 minus x square.
Mm-hmm.
Now since t is minus x by 2, x is equals to, we can substitute t as minus x by 2 and find what x is, right?
Mm.
So t is minus x by 2. When you put, you get x as minus 1, correct? And when t is pi by 2, x is 1. That you know, right? These are the
Yeah.
two sign values. So the Cartesian equation is y equals to 2x times square root of 1 minus x squared, where x is between minus 1 and plus 1. So k is 1. That is
Yeah.
how they have the value of k, right? So whenever we have a sine function within this particular limit, the x values and the y values will be between plus and minus 1. Is it okay?
So can we do the same thing with, when you were trying to isolate y? So cross multiply the 4x squared.
Yeah. Same thing.
You
Okay,
can get same answer.
Yeah, reduce the screen. Let me complete my work. No problem.
Just wanted to see
Yeah.
your method. So I
Okay,
can
so,
use both.
yeah, this was straightforward. So y squared equals to cross multiply. So we get 4x squared, right?
Yeah.
Times 1 minus, times 1
Minus 4x to the power of 4. Oh, yeah.
4x.
Okay.
Now you square root it, because y will be square root of 4x squared, which is, we'll take out 2x outside, 1 minus x squared. Is it okay? So
Mhm.
we get 2x square root of 1 minus x. Is that clear to you?
Yeah.
You could have done square root here itself. So then also you would have got the same result. Anyway, so we have the same result as book, slightly different method though, doesn't matter. So we have y equals to 2x within square root 1 minus x squared, correct? Now
Yeah.
you have to work on the range of this particular function. After all, what y is, right? So
To sketch it.
yeah. So what is x equals to, right? X is sine t. So y is
Yeah.
2x times 1. So you know that the domain was between minus pi by 2 to plus pi by 2, correct?
Yeah.
X is equal to sine t, correct? When you plug sine as minus pi by 2, you get minus 1, correct?
Mm-hmm.
And if you plug in plus pi by 2, you get plus 1. So that is the value of x. You understand?
So we have to sub in x pi by 2 into x equals sine t.
Sine t, yeah, because t is that restriction.
Oh, so x is between 1 and minus 1.
Because they use the parameter k is equal to 1.
Right, okay. That makes sense, yeah. That's clear.
Correct.
Got that.
Okay, so let's move on to some other examples. You can take questions.
Let's quick flip. Maybe we can try yeah, one of these or
Yeah,
on
okay.
the right hand side.
Let's take 8. It is saying a curve C and circle question for you. You want circle question, right?
Yeah, I actually do like those questions.
Correct. But do you know the formula of sine 3t?
Sine 3t.
Yeah.
Yeah.
So
2t plus t.
write down the question. X is equal to 1 over 3 sine t, okay? And y is equal to sine 3t.
Wait, so you're making this up?
No, it's given question 8.
Oh, wait, what are we looking? Oh, 8. I thought you said 1a. So I was like,
No,
oh,
those
sorry,
are
let
very
me just
simple.
quick shift.
Those are very simple, right? So I thought we'll skip all those. You do them.
Oh, yeah, that's all right.
So you do all those questions. I'm looking into those circle questions.
Oh, yeah, no, that's cool. Okay, so a third sine t.
And t is between 0 and pi by 2, not including pi by 2. Okay. Correct. So that is your function. So when I say x is 1/3 of sine t, and x is between 0 to pi by 2, basically sine curve, you remember how it is, right?
Yeah.
So 0 to
Nice
pi by 2 means we are looking for this, right?
Yeah, is there a horizontal compression of a third?
No, we are looking into x value first.
Oh, okay.
X value. So that becomes your domain x value.
Oh, yeah,
Value for, because when you convert to Cartesian form, x becomes your domain. You get the idea. So the range of x is the domain of your Cartesian form, correct?
Oh, yeah,
So
domain is the range of x.
Range of x is what? Range of x is from 0 to 1. Is that okay?
Yeah.
And now, let us find range of y.
Oh, so you have to work them independently.
Yeah, just work independently. So when you plug in 0 here, so it is of course 0. So it is from 0, not including. And if you plug in pi by 2, so what is 3 pi by 2? Sine 3 pi by 2.
Just do calculation. Sine 3 pi over 2.
So look at, when you are looking into sine 3 pi by 2, then your function basically within 2 pi will have 3 revolutions. You understand?
Mm-hmm.
So when you plug in 3 pi by 2, so it goes through 1 pi by 2, 2 pi by 2, 3 pi by 2. You get the idea. 1 pi by 2, right?
Yeah, so we're doing the range.
Sine 3t means there are 3 waves in 2 pi.
Yeah.
Is that okay? So 1, 2, and then 3, right? So within 2 pi, we have 3 waves. Is that okay?
But so do I do sine 3 pi over 2?
No, we'll plug it later.
Okay.
First,
Cool.
we have to understand our graph. Where are we? Correct? So 1.5 waves. So 1 wave and then 1.5 waves. Somewhere
is
here.
Is each wave counted from trough to trough? Or from.
So it is 2 pi is this much, right? So 1, 2, 3, 4, 5, 6, right? So each here is how much? Divide by 6 will be pi by 3. Is it okay?
Yeah.
Do you see that? This is pi by 3. Is it okay? This is 2 pi by 3, right? Scale.
2 pi over 3. Yeah.
3 pi by 3 or pi, right? You want
4.
the value pi by 2. So pi by 2 means we have already gone through the full cycle, plus and minus 1. You get the idea?
Yeah.
So the y value is from 0 to, it goes to 1 also and minus 1 also. Is it okay?
Yeah.
So this is from minus 1 to plus 1. 3 pi by 2. So 2 pi by, so 1. So this is pi for me. This is pi by 2. So 3 pi by 2 is more than pi, correct?
Mm-hmm.
So we have gone through the whole cycle. So we have plus and minus 1. So range is full range from plus 1 to from minus 1 to plus 1. You get the idea?
So wait, so it's the range of
Y.
the range of y is the range.
Range of y is the range, correct.
Yeah.
So the range
So
of your Cartesian equation is from minus 1 to plus 1.
Yeah.
Minus 1 to plus 1.
So you're not gonna do so you won't sketch. So you know the y that's given, y equals sine 3t.
Yeah,
You're not gonna sketch that and then say it's between, you would sketch like you did there. And
I will sketch this and say range of this, range of my Cartesian equation.
Ah, cool.
Yeah. In between we have plus and minus 1, both are included.
That's clear.
So now, very clear, let's write down the domain of this function x is going to be from
0 to 1.
And the range, which is the y value, ultimately is from minus 1 to plus 1, both included.
Yeah.
Because these points are included. Do you see that?
Yeah. Whereas 0 and 1 for the domain, it wasn't included.
Correct. So now let's look into the equation. They didn't really ask for that, or did they? Please read the question.
They did at part B.
Okay, at part B they asked. Okay. But first thing, as I told you, you should look
always
at the domain and range. Okay.
Yeah.
Right. They misguide you at times.
Yeah, because it's hard, especially when it involves graphing, going straight to that question without setting the foundation in the beginning of the question.
Yes.
Your mind can't get in that mindset. So I think it's, like you said, always important to start with that.
Start with domain range. Okay. Find the range of x, find the range of y. Domain of the Cartesian form will be range of x, and range of Cartesian form is range of y. So we have got domain and range of Cartesian form. Is that okay?
Yeah, immediately from that. Yeah, that's clear.
We haven't derived the Cartesian form. No
Yeah.
We did part B first.
Yeah, that's why, like you said, they misguide you because they want you to do the equation first and then from there find domain range. That is
very difficult. You don't know what you eliminated, what you did not, right?
Yeah.
Right.
Really hard.
Remember, the domain and range of Cartesian form is independent of the final equation. It really depends on the parametric equation. Is that okay?
Yeah.
That's it. Okay.
That's really clear.
We can now erase the screen and then read what really the question is and then move forward. Correct?
Yeah. So part A was saying, show that the Cartesian equation of the curve is given by y equals ax 1 minus bx squared.
Okay, so that is what they want us to prove. We know that's the Cartesian form, right? So we are given x equals to sine t, right?
A third sine t.
Oh, 1/3, okay. Yeah. And y
equals sine 3t.
Sine 3t. Correct. Since you do not know what is sine 3t, we'll have to derive the formula for sine 3. Is that clear to you?
Yeah. Can we use 2t plus t and then compound and go?
Yeah. We can use and then we can apply it twice. Is that clear?
Oh, is that in terms of does that mean deriving?
Yeah, deriving.
Oh, okay.
If you know, you can put it directly. Is that okay?
Oh, do people know?
Yeah, of course.
Oh.
So let's derive it. Okay, so y equals to sine of 2t plus t, right?
2t plus t. Yeah.
So that is equals to sine 2t
cos t plus cos 2t sine t.
This itself a very big exercise. You see that? So sine 2t is
that's why it's 5 marks.
Sine t cos
t. Sine t
Because there is
cos
already
t.
cos t, I'm making it square. Is it okay?
Yeah.
Plus, we have
Cos
cos
2t
2t.
can be written in three ways.
So write it in sine. So
Okay.
1 minus 2 sine square t. Mainly
Times
because
sine t.
x is given in sine. Is that okay?
Okay, yeah.
Expand. So 2 sine t cos square t plus sine t minus 2 sine cube t. Is that clear?
Mm-hmm. Do we write the cos squared in terms of sine?
Yeah, 1 minus sine square.
Oh.
But you could take 2 sine, but that gives you minus, not a plus thing, right? Cos
Yeah.
2 was 1 minus, so it gives me minus. Right. So now replace cos square t by 1 minus sine square t. Is it okay?
Yeah.
So let's write down that. So
Minus 2 sine t
2 sine t
plus 2 sine t.
1 minus sine square. So then minus 2 sine cube t, right?
Yeah.
Plus sine t minus 2 sine cube t. Is it okay?
Uh-huh. So I got
So,
minus 4 sine cube t
correct.
plus
Minus
3t
4 sine cube t
plus 3 sine t.
plus 3 sine t, correct. What else? Nothing else, right?
Nothing else. Yeah.
So do we get sine t common? Can we write now in that form? Yes. So
Yeah.
we got sine t common, right? They want us to write 3 sine t common because they want 1 in the bracket. You see that? Ax.
Yeah.
So we'll take 3 sine t. So y equals to 3 sine t common, correct? So we get 1 here minus 4 over 3 sine square t.
Y equals 3 sine t. Yeah. 1 minus 4 over 3
So
sine
sine
squared
t
t.
is x, right? So we get 3x. 1 minus 4 over 3 and x squared. Is that okay now?
Wait, sine t is x only because of the layout.
It's given, right? X is equals to sine t. Parametric equation.
I thought it was x equals to a third sine t.
Oh, yeah. So put third sine t. Sorry. So x, 3. So write 3 times. Sorry. So sine t will be 3x, correct?
Yeah.
So 3 times 3x, 9 of that. 9x of that. 9x. And 3 put, what am I saying? Sine t is 3x, okay? Let's rewrite it. Put sine t as 3x. Good job.
Okay. So 3 times 3x.
Yeah, I forgot. I
Oh.
wrote that 1/3 later, right? So 1 minus 4 over 3 and x x is sine square t will be 3x 9 3 square is 9, right?
9. Yeah.
Now
So
simplify.
with the, do you have to simplify? Yes. Yeah, so in terms of simplifying, would you do 1 minus 4? No, make the 4 thirds times of 9.
Yeah, 12 square. 12 x square. Is it okay?
1 minus 12 x squared. But yeah.
Now you can write a is what? A is 9 for you. And b is
And b is 12.
12. That's it.
Because the minus is there. Yeah. All right.
Does it make sense to you?
Yeah. So I learned, really important in terms of writing domain and range first.
Correct.
It looked in the beginning in terms of sketching. Look at asymptotes just in case. Look at the maximum minimums to make sure you're getting your range correctly and not just assuming when you put 0 in, it'll all fall into place. And then in this case, it's in terms of putting things in the Cartesian equation but involving trig. So this is where you bring in your identities, as well as substituting x for like sine t or 3t, and maybe you need to change domain in certain sections. But yeah, so just remember domain is the range of x and range is the range of y.
Now, Amy, look at this equation. Right? Y equals to 9x times 1 minus 12x squared. From this equation, can you tell me domain and range? And we have a
No.
And we have a condition that t is between 0 and 2 pi. Hell,
Yeah,
you
that is so
cannot,
hard.
you cannot. Let's, I mean, for a
Be
student in
realistic.
examination,
Yeah.
they will have to skip part B for sure.
Oh,
So
yeah,
what
because
we
you're
did,
completely, yeah. So always look at the parametric equations in terms of finding domain and range. Can't believe they would do that.
this is a polynomial which does not have any restrictions, correct? And working
Oh,
on radian value 0 to 2 pi on this polynomial is very
too
difficult.
hard. Yeah.
You cannot work on it. Therefore, first
Oh,
find domain and range, then get your
yeah.
Cartesian equation, put the previous domain range in part B. That's it.
Right, right. I'll follow those steps, sir. And
Right. So I think you have understood the whole process. How we do these
yes.
equations, whether they are trigonometric or they're straightforward. The straightforward equations also lead to very good curves, right?
Yeah.
You'll soon discover they may not be functions. You should remember one thing: most of the curves which you are dealing with are not functions, right? So for one value of x, you may have two values of y.
Two values. Yeah.
So
So it would fail the horizontal or vertical line test.
yeah, they will fail. So not necessarily. So parametric equation, for example, circle you saw is a parametric
Yeah.
equation. It is not a function, right? So
Right.
many parametric equations will not be functions. However, we are now in a position to simply write down that equation and split into x and y and
Yeah.
easily make them. That's the beauty. And so
Oh,
can you
yeah.
summarize today's learnings, Annie?
Yeah, so yesterday was more looking at, just understanding parametric equations, but today was applying it in terms of trig and involving that and a bit more graph sketching. So still looking at domain and range and following the same steps in terms of isolating t. It's just that when you bring in a bit of trig and a bit of sine, you're just trying to remember those rules in terms of, like if it says sine 3t, using your compound angle formulas, maybe your double angle formulas as well, and trying to simplify the equation accordingly to what the format they want it in. So yeah, we saw certain answers when they asked for 1 minus a certain thing. You have to make it into that form, not just factorize however you want to and simplify. And yeah, certain things, I was asking about how do you know if to take out the negative sign or not. That's when you look at the format and check accurately what they're asking for and then
Yes.
do so.
So
Yeah.
relate to what you really need, right?
Yeah.
Apply all the techniques to the context wherever it has
Yeah.
to be applied and get your result as per their need, right? Not just do it.
Do whatever. Yeah.
One thing very important is where we will not follow them is
Domain
always
range.
start with domain and range.
Yeah.
Whether they are asking or not asking,
You
even
do
if
it
they're
anyway.
not asking, find domain and range.
Yeah. Yeah.
And then start your work. At least you know what are your restrictions, and so
Mm.
that is going to help you to write down the final answer in any case.
Yeah.
Is it
No,
okay?
like you said, yeah, even though they're not literally asking for domain and range, it will definitely, like, hands down, help you in the question. Whatever question they're asking will work. It will be incorporated, so you might as well do it. It will only do good, so it's all right. Yeah.
Great.
Thank you so much, sir, for today's
My
lesson.
pleasure.
I learned a
My
lot.
pleasure.
I appreciate it.
Thank you.
I'll
All the
see you soon, sir. Thank you. Bye.